Hi, myself Anil, and in this screencast I'm going to show you how to set up Tyler. Tyler is a proof of concept implementation of what we imagine stores to be in the future. Stores using Tyler are manned by bots which act like salespersons. We use a set of overhead cameras to track people's movements and automatically move bots around using this information. When a customer engages the bot, he actually talks to a person who's sitting remotely at a call center, thus giving the concept of a virtual salesperson. This gives many benefits like the reduction in the manpower needed and the flexibility of work location. We move on to the actual setup in the next part. The Tyler system mainly consists of three different parts. I'm going to show you what the three different parts are and how to set them up as we move. So I've downloaded the zip file here, th03 underscore athena.zip. Let me just set it up. Uh, Currently the demo is running on Mac, but the installation instructions for Ubuntu are given in the README file. Assuming that you have virtual env set up properly, let me just set up a new virtual environment. Let us just have a look of what the code actually is. So Tyler underscore demo is a new folder that I created. Once you go into th03 underscore Athena, the code folder, you'll find three different pieces of code. The fb5 underscore arm, which contains the bot code, PC, which contains the PC code, and Android. Well, there's no code really in Android, but the README file is worth a read. Let us start with the bot code. The bot code actually needs Windows to run on. You can open the code in Keel, but we already provided the bin file here, serial underscore com underscore xb.bin. You can just copy paste this bin file onto the Firebird and it'll work. The bot code essentially implements a Zigbee communication with the host computer. You can send the bot commands like move forward, stop, or say rotate by X degrees, and it'll do the command. The host code actually maintains the state and the bot code just moves around based on the commands it's given. Next we move on to see how to set up the PC code. Let us now move on to set up the PC code. The PC code consists of two parts, the host and the remote. The Tyler is divided into three parts, as I said previously. There are bots which are present in the store, there are overhead cameras which are present in the store, and then there's this computer which processes the overhead camera feed that we get and uses this information to move the bots around. There's a remote computer which is placed remotely, and this is where the actual people are sitting. So anytime a customer interacts with the bot in the store, a request is sent to the remote, and the remote then engages the bot remotely using WebRTC. So now let us set up the host code. Uh, Before you set up the host code, you need to install Node.js and npm. The installation instructions are given in the README file. Once you have set up the Node.js, you can do npm install package.json or simply npm install and then hit enter, and this should install all the necessary packages. Similarly, you need to do pip install. This will install pip install -r requirements.txt. This will install the necessary Python packages. The host code is again structured into two parts, the tracker and the client. The tracker essentially implements the OpenCV routines. We have two OpenCV routines. One is used to track people's movements using some HAR cascades motion tracking algorithm, and the second is bot detection algorithm. We use color-based object detection for that. Since the installation takes time, in the interest of time, I've already set things up here. Let me just run the once you go into the tracker folder. We are in the tracker folder right now. There's this tracker.py file. You just need to do python tracker.py. Let's hope this works. As you can see, there are a number of things. It says started HTTP server on port. So the tracker exposes the information that it gets using a HTTP server. There are two windows that you see. The first window implements object detection. So anything that moves gets this blue dot up on top of it, and that's kind of the center. So when you have an overhead camera and people move, this blue or yellow dot actually comes on it, and that's the position that we require. Then there's the rest, which is currently black, but if you put a dark pink color paper on top, or you show it, it comes up as a purple colored block here, and that is kind of an indication that the bot is present at that location. Next, we'll go on to set up the client code. Now let us move on to set up the client. The client is essentially the bridge between the host computer and the bot, and also the host computer and the remote server. The host implements mainly three functionality. It initiates communication between the bot, essentially sending it directions to move around based on the video feed. It communicates with the server to actually see if there are some manual overrides being done. And the last thing that it does is it sends the bot presses that it listens to from the bot to the server. Before you run the host code, you need to ensure that the Zigbee module is actually connected to your system. For that, you need to install some drivers. Assuming you have done that, to run the host code, all you need to do is cd:/client and node host.js. That's all you need to do. This host.js initiates a WebSocket communication to the server and also does the USB serial communication. Since both of them are blocking, we needed to move this to an event-based language like JavaScript. Python didn't really work in this case. Next, we'll look at how to set up the remote code. In Tyler, the remote sits at a different place, actually remotely, and the operators, many different humans interact with the store installation by sitting at this remote location. Let me show you how to set up the remote code. The remote code is present in remote slash, so let's go into it. All you need to do to set up the remote is do node http server.js. This will set up a node server for it. Let's just reload the page here. So you need to go to localhost is to 8080, which is the port number. You see the interface basically. You can engage one of the bots by selecting an option here, and if you get any pings from the bot, that's a button press from the customer, you'll see the pings here. Now let's say we click on bot 0. You see the bot interface here basically. You can use the left, right, up, down keys to manually control the bot as to where it moves. And you can do start video. On clicking start video, if you have a bot connected at B0, then it initiates an audio video communication. Essentially the browser, the Android phone present becomes one terminal, and your webcam here becomes the other terminal, and you have a video Skype like call that's happening. You can see what the basic WebSocket communication happening here. That is all there is to the setup of the PC code. The last bit is the Android code. The README gives clear instruction on how to set up the Android client. The Android phone is set up on top of the bot, and you need to install the latest Chrome browser on it using the Play Store. Then open http:// server IP is to port /client/b0. In this case, it will be http:// localhost is to 8080/client/b0. If it's not on localhost, then you need to get the appropriate IP and set the port, and then open this and leave it open. Anytime you hit the start video button there, it's actually reaching this point. Hope you like the Tyler concept. Let us know if you have any questions. We'll be happy to answer you. Thank you.